Hey, St. Mary Grade 8s, Mr. McHenry back with another math lesson in our unit on probability. Today we're going to be talking about simulations, and maybe when I say that word, some of you make a connection to the game Sims on the video game there. Not sure if that's a game that is people are playing now or not, but a connection there. So a simulation is a probability experiment that imitates a real life situation. And we have a simulation model must have the same number of outcomes as the real situation. And that word model is maybe something that you are hearing in the news because they're running different simulation models with regards to COVID-19 to predict what might happen. So this is real life stuff happening with regards to simulation modeling. So again, a simulation model must have the same number of outcomes as the real situation. So a coin can model for if the real situation has 2 outcomes. A cube with 4 sides can model for a real life situation that has 4 outcomes. A cube with 6 sides can model for a real life situation that has 6 outcomes. And a spinner can be divided into n equal sectors. So it could be divided into 2 equal sectors, 8, 10, 12, okay, depending upon how many equal outcomes that you need. So we're going to get right into an example. We want an estimate of the next 100 babies born at Oakville Hospital. How many will be boys and how many will be girls? Well, we could go to Oakville Hospital and we could sit in the delivery area and we could wait, and every time that a baby is delivered we could get that information and record it, but that would probably take a long time, and we don't have that time to sit there and record that information. So what could we do? We could simulate that. We could conduct a simulation. So a baby being born has 2 equally likely outcomes. It could either be a boy or it can be a girl. And so we want to conduct a simulation that is the same as that. And what could we use? Well, we could use a coin because it has 2 sides. We could say heads is for a boy and tails is for a girl. Okay? And what we could do is we could conduct a simulation. So what we're going to do is we're going to toss the coin 100 times. There's a head, so we record that as a baby boy. We would toss it again. Okay, tail, girl, and we would record this information. Toss it again. Head for boy, and we would continue on recording that information for 100 simulations. All right, and we want to toss the coin 100 times, and that's probably we need to have at least 100 simulations to have enough trials. Okay, so we record the results, and head appears or a boy 54 times, and tails or a girl 46 times. So therefore, an estimate of the probability of a baby being born as a boy is the number of times heads for boy appeared divided by the number of simulations conducted. Well, how many times did heads for boy appeared? 54. How many simulations did we conduct? 100, which is equal to, we divide that to a decimal, 0.54, or percentage 54% boys. Okay, again, this is an estimate. An estimate of the probability of a baby born is a girl. Again, the number of times the trials tails for a girl divided by the number of simulations conducted. Number of times tails for a girl, well, that was 46 times divided by the number of simulations conducted, 100. We get 0.46 or 46% estimate that there would be girls. Okay. We want to go into another experiment. So one's a little bit more in depth. All right, so in this example, we want to design a simulation to determine the probability that 2 out of 3 grade 8 students have their birthday in the same month. Okay, so we have to think here. Well, how many months are there in the year? Well, there are 12 months in the year. Okay, so the probability of being born in a particular month is 1/12. Okay, so we need a simulation that has 12 equally likely outcomes. So we have to think about this. What can we do to have something that has 12 equally likely outcomes? Well, probably the easiest thing is to have a spinner. Okay, so a spinner with spinner divided into 12 equal sections. Okay, and so to conduct the experiment, what we're going to have to do is that for each simulation, we're going to have to spin the spinner 3 times. Once for each of the students. So we have 3 students. So we would conduct it and we would spin, okay, land on August, mark that down, spin again, landed on July, okay, spin again, and it landed on May, and we would say nope, for that simulation it wouldn't have a match. So that's one simulation done, no matches. Okay, and we would do that 100 times. So each time spinning the spinner 3 times. Why do we spin the spinner 3 times? Because there are 3 students and we want to see if it lands on the same month 2 times out of those 3 spins. Okay, so we're going to record if any month occurred 2 or more times out of the 3 spins for that simulation. Again, we're going to conduct it about 100 times. So we're going to do 100 simulations. Of spinning spinner 3 times. And again, why do we spin it for 3 times? Because it's once for each of the 3 students. Okay? And then we can say that an estimate of the probability that 2 out of 3 grade 8 students have the same birthday month would equal the number of times two or more months were the same divided by the number of simulations conducted. Okay, so that's the lesson for today. We didn't have a lot of stuff written down for today, so if you want to go into the lesson notes to look for some more of that information that was spoken about as opposed to written down, please look for that information in the lesson notes. And as always, please do your practice so that you can be feeling comfortable and confident. If you have any questions, you can always contact me by email or again using Mathify through TVO, where they have online tutors there to help you. Take care, everybody.